Greeting you. Well, vulnerability. What is vulnerability? There are, of course, technologies, means in our life that are there to serve our security or eventually use in security, and yet they are vulnerable. Most of our life, and practically myself, for the last 10 years, also these 2 days, I devoted to draw attention to this vulnerability. Not to say what is bad or inapplicable, but that we should know what is the risk to use these. That on our part, we are, of course, dealing with testing security products and solutions and their vulnerability. Our topic today is the face recognition systems, practically 2 systems for face recognition, and we would like to present to you the vulnerability of these 2 systems. What we talk about? First of all, I would like to introduce to you our institution. We owe that to our institution, also to you, to all of yourselves. And then Csaba will come and talk about the principle behind of these topics. And also, as it wants to be also a presentation, also in practice, we would like to show to you how we can cheat this system. Now, where did we come from? From the Óbuda University. Your Óbuda University has been created by the integration of several different high schools, Banki, Kandó, and some others. And it is within this framework that there is the Applied Biometrics Institute. And I am Feher Andras, the managing director of this institution. And we can already say today that we unite there all the we unite all the knowledge and of these 3 institutions, that is the Banki, the engineering, mechanical, and electrical knowledge. And if we are engineers and we want to say something wise, then we would like to illustrate that by pictures. What is our concept of security? How we think about that, not in compartments, taking it apart to communication to whatever else, but as in one, and to illustrate that in the way that security is from the physical security to information security, to assessment of the risks, of the vulnerability. And all that combined together, can we say that this is how we can talk about security science. And if we look further, then of course it also involves all the different standards and regulations that we have to take into consideration, and even further on, even beyond. Now, what do we deal with? That is, we perform audits as our clients order it from us. Of course, we provide education, training, and education in any setting that there is a need, where there is a need for that. Also here we are there, and we are doing tests, certificating, and also basically, of course, security tools, devices, and technology. And this is what we are about. So why we have a need for that? Of course, we don't have the time to go into plenty of details, but the first thing that is important is that today, not only in Hungary, but all over the world, there is an integration of technology which maybe precedes knowledge. I don't know whether there are some of us that there is the microwave oven and how you can handle all these services. I cannot handle all of this, all of the details of what it is capable of. But that is not the main point. But even all this technology, there is much more available than what actually is covered by our knowledge, and even by the knowledge of experts and professionals. And there is no objective platform to get sufficient information that there are tasks in economy, projects in the economy, there are investment projects, and this is what that require responses, and we have to react to these requirements. And how can we get information? Even the professional, he can get information from the information of the manufacturers, of the vendors. But here we are mostly confronted with the fact that whatever we have in the data sheet and in the various documents and papers those facts, capabilities, whatever, will not mirror correctly the reality. We say that the independent certification, we are the independent certification agency that will look at reality, and we shall try to put it into a realistic environment, an environment of reality. And our objective is not to downgrade, to discredit any kind of a technology or solution, but our approach is because the biggest fault that we can commit is that we consider that something offers 100% security and while it does not. That is already a problem if we consider that anything can provide 100% security. So our objective is to point out that a particular product, what is it capable to do and what is it not capable to do. We are a university institution, and we are independent of the manufacturers and from the vendors, and we try to cooperate, to engage in a realistic cooperation with all professional associations and groupings that we think are in the forefront of knowledge in their particular field. There is the National Security Investigation Agency and some other international organizations I could mention, but there is one thing, that it is always the task, the mission, and the application to find the appropriate solution that we are focusing on. And of course, last but not least, we would like to introduce those ladies and gentlemen who cooperated to ensure that the lecture of today could be made, and I would like to point out that is Csaba Otti, who is the director of our research and development department, and there is also Arnold Ősi and Balázs Bencsik, who also have a credit in bringing about this lecture. And now I give the floor to Csaba Otti. Of course, if Andras gets in to his lecture, then it's very difficult to stop him. Now I'm Csaba Otti, and we'd like to tell you in a few words what shall happen now. First of all, a little background concerning this technology, how our tools are performing. Of course, there is also the content that we don't see and we don't have here. We shall also have a look at what are the problems with these devices and what are the challenges there. This will be the theoretical part, and after that there will be a practical part as well, which is will take up the major section of my lecture. And for that, I would like to ask for two volunteers with whom we would like to produce the tests with the equipment. So please think about it already right now, who these two volunteers will be. Of course, the specs will have to be taken off, and of course, with the long hair, then of course, then it will be then trapped behind. Of course, it will be. We shall need a darkness in the auditorium, because of course we shall ask for the volunteers if there is any problem. We shall fix it at the end. Now let me start. Then what do we talk about it? Surveillance, video camera surveillance. You know what about it. These are CCTV cameras, the closed-circuit television that is used for all sorts of purposes, for good and bad purposes, by different organizations and companies. And what we can see is that if we talk about biometrical identification, then one of the fastest advancing technology is now face recognition. It is used for many purposes. I will show you on the slides that will follow. And the reason is that this is a contact-free technology, because people are afraid of touching certain devices. And let me tell you that we are participating with the auditing of several companies that are introducing such systems, and we are experts auditing them, and we are collecting the information observations that we receive. Let me tell you about the winner. It is a young lady who sends the message that if somebody is masturbating at home and puts the hand on that device and comes back and gets pregnant, who will pay for the so now it was a card system, and there was the card on the neck, and of course then the card can cut a throat. cut your throat. The car can cut your throat. So these are fantastic. These are, of course, false pretensions and fears, false fears, and where these false fears are coming from. Let's see CSI. There are very plenty of wise people sitting there. Wonderful photo that we raised. If we zoom in, what can we see? We zoom on and further on, very much so. And then what we see, it gets clear enough. And that is what it does. If there is no information, you will not get information. What are the applications and why are they important? The area surveillance to identify terrorists. That is, for example, systems at airports in the US, in other places. Very many of them are installed in different parts of the world. This is we don't have enough time. It's very interesting. It's also used for commercial purposes, behavior identification, access control. And this is the last thing, this latest thing that we shall talk about. What is the real difference between these groups, between the first four and the last one? The real difference is that in the first four category, the precision of the system will not count, is not important. So if I put a system for area surveillance and to filter and to find the wanted people, of course we are happy if we get one, but we shall not find the other ones. But the problem is that there are plenty of false identifications with these systems, and the result is that if it is introduced in an airport, then they send the false report, then all the commando people are there on some innocent people, and the terrorists are running away. But this is not what we are talking about. We are talking about security access control, that really those who are authorized can get through. So there we try to achieve 100% performance level. How do face recognition systems work? Now we shall show you in a few slides how it works. There is the visible spectrum of light and it is on a very limited spectrum that we can see, of course, from the violet to red, and there is the infrared section that follows, and these pieces of equipment work in the infrared zone, which is, of course, invisible for the human eye. But of course, for the cameras, it is visible. So why is it important? Because it's a mystical thing. It's very secure. We never heard of that. It's much easier to process that image. We shall show you how it is that we can even process a picture with much less detail. What is the functioning of the human eye? You can see these three curves, the green, red, and black. This is the RGB, and then we can see that about 700 nanometer is the processing capability of human eye when it comes to detail, and then it is the camera for the black line, and it is very easy to see that with a normal CCTV camera, its range of identification is above 1000 nanometer. Why is that a problem? You can also see the intensity, that it is quite different from that of our eye. And how we can notice also with the human eye these weaknesses. We can test it. If at home we shall only put some black stocks in our drawer and only one yellow, then of course the light becoming stronger and stronger, it will be always the yellow that we first see, because that is the type of color that will reach our eye receptors first. Now if you come back to that, it is the incoming light that will have to be cut at the top. So we need an infra filter, so that from the infra range spectrum, not all we would exclude all that elements of information, not to disturb all the rest. So this is on that right side, which I showed you before, that we work on the infrared spectrum. How face recognition works? We try some articulate points. This is the eyes, the edge of the noses, the forefront. So with the spectacles on, the results are much worse. Also a hairdo, where the hair covers part of the face, that is also much more difficult. And the algorithm used by various manufacturers are always different. So what are the challenges when it comes to these devices? For example, the angle of vision, also uncovering the face. For example, I take another specs, and then the system will not let me through. We are also getting older, so our facial expression also changes. So these are all matters that, and you will see that on the next slide, that is always different. And how that device is working, how the algorithm is tested. Now, if we take such a device, there is a data sheet to go with it, and then, of course, it is explained quite clearly that if there is the ratio of false refusal, and that is what is the percentage, and of approval, and of course the false refusal is about 0.000 something. Of course, the good thing would be if it would be 100 on one side and 0 on the other side. Now, the phenomena is the following: if in the U.S. somebody wants to get in, then we have to go through the algorithm of the system, and if you get the appropriate authorizations, then of course then you can get through to the American government agencies.
The problem is that these are software algorithms with images prepared in advance. Just imagine comparing this, having to compare this with a live person approaching the camera. You remember all the terrorists in the U.S. lately wore baseball caps in order to confuse the face recognition systems. This is one problem, and owing to this, the real false rejection percentage is around 10 to 15%. We know this is the case. The 0.000 something is simply not true. And now for the practical part, which will have a very complex process. First of all, I'd like now those two persons who are willing to provide each a face for the test. Yep, that's one, two. And I'd like to see the image of the handycam projected. Right, this is it. Say a few words about yourself. This is my second Hacktivity. I feel great. Excellent, thank you. This is my first time at Hacktivity, and I'm a sysadmin in Kecskemét, Hungary. So please go to my colleagues. This is the Face ID camera image. I debated with myself for a while whether to tell you the name of the system. Well, I'd like to show you what this technology can perform. The whole presentation wants to show you who are or will be security specialists and will be faced with the use of security devices. Please doubt these devices. Always doubt them first. The system itself looks like this. Good. Not much is to be seen. It has a small display which shows the radar turning around. The two bottom cameras, one of them photographs in the visible range and the second one in the infrared range, and it actually only uses the infrared range. Everything else is just eye candy. Now we need to register the two colleagues. First to check that they are not yet present in the system, then we'll register them. It's all just to show you how this whole process works. A little HP advertisements, hope they pay for it. Oh, they won't, but if they want to, we are available. So here you see that it is trying, it does not reject, but at least there is no hit in the system, so the person is not yet present in the system because he's not registered. At this moment, he is being registered. You see the process, you push a few buttons, and all of a sudden the person gets a user code, some name. The essence is that we will do the whole process. The essence is that my colleague holds this device roughly in the height of the person's face, asking the person to move his head up and down or left and right. This seems to be a security function. Would you would think, because in order to have a 3D image, but this is not correct. It's just to make sure the face is the one we want to have. In many cases, when we participate at such tasks where we need to give access to a large number of persons, then you are unable to be so accurate. I've seen cases where lots of people were waiting outside in the snow and they were being photographed and were being held up and would not be allowed access to the building. Well, anyway, this is successful now. The person has been identified. We will repeat the same process for the second colleague. I hope we have time enough to do the whole process. He will also be first rejected because he is not registered in the system. Then we will register him as we did with the first colleague. Why this is performed, let me tell you that we can test these devices in the dark. We don't see in the infrarange. And this is why we actually ask the lights to be dimmed. Our institute is in a building where we have large windows. It's very hard to darken them, so we need to do tests in the evening or early in the morning, which is not really well loved by the portiers. So we actually had to ask for the key of the machine room, which is very, very dark. And we did our work in the dark, and all of a sudden the door sprang open, and there was the janitor screaming, "What's going on here?" He saw three men doing something mysterious in the dark room. Well, this is the way we live. So the second colleague has now been registered. Now we have 2 registered volunteers, and the next step is when we show you the devices that we use to handle these instruments. This is a paper box with a web camera inside, with the infrared filter taken out of it, removed. It is a simple and cheap camera, a homemade little motor mechanics that sets the focus, and in the background we see an infra lighting roughly in the range where these devices needed. Last time we did a vulnerability test and a device, we sent it to the manufacturer, and they said they're not going to use such homemade somethings. But that was exactly our goal, to be able to do acceptance testing on a very expensive hardware. Well, I'm only happy if it don't require a cheap device to do so. Okay, so this is the box that we use to do our testing, and now we'll try to create their image in the infra range. You will see what the instrument will be doing. Not quite there yet. While Balázs is working away, let me tell you that the second phase will be using another device and a gypsum plaster mask we made of Arnold. Just tell me when you're ready. Are we done? Okay. I'll continue this story later on, how Arnold got a plaster mask. And now, please, lights off. But only when our colleague is already sitting in the corner, because otherwise it'll be hard to not stumble. Now, full darkness, please. And let me show you what we see in the infrarange. Nothing. Well. And the reason is that we are watching the wrong screen. We need the laptop number 2. This is the infrarange image. The infrarange is a very liberal range, so to say. It's not very detailed. Even the beautiful people look a little less beautiful than they normally are, and ugly people get even uglier. But the essence is that we try to use this infrared camera to create a photograph that will be suitable for the equipment. Next volunteer, please. I love the infrarange because I look like Darth Vader without his helmet in this range. You can actually achieve to show someone looking like an alien. Try to get a face that you can reproduce. Okay, that's good enough. A lot of pictures, please, about this. Okay. We can switch on the lights again. We now have infra photos with about these 2 volunteers. We'll just mess around a bit with these photographs. I hope Balázs knows which one to load. I'll tell you why this is needed. We now use a image manipulation program. We need to pull down the blues a bit, make it black and white, have a dark background. These are all important things for using the device. And it seems that there is no generic solution. Each device needs to be checked individually, and we haven't found any device that didn't have some sort of issue. If a fingerprint identification program is used, it is one of the most safe technology. It identifies immediately, but even the manufacturer of the largest iris identification system was able to offer an equipment that was better than that. Hopefully they'll reach that point. So what happens is that we mess around a bit with these images and then we'll print them. Anybody nodding? Right. So we'll print them. Last year, at this moment, it turned out that the printer has run out of paper. Well, we do have paper now, right? Okay, we have the two prints. Show it to the camera, please. Well, well, this is a paper, not piece of paper, not a face, or a very flat face in that case. Okay. Now let's use that piece of paper. We want to see the image of a handycam. Right. Both volunteers have been registered. It is always a problem when a biometric device starts recognizing the sample. First of all, it identifies the image as a face. If there is no live sample, we normally say that it only depends on your dexterity to find a sample that is not a face and still get recognized as a face. This light may be disturbing a bit for the, or a problem for the equipment. We work with probabilities, so it's not always a success at the first run to do this identification based on the prints. It severely depends on the lighting conditions. Well, seems to be not an easy task. Let's start with the first image, which seemed to be easier to use. Right, this is better. Better lighting for the processing.
Látták, igaz? Mondjuk nem sokáig van kitéve azt, hogy ez sikeres azonosítva, de egyszer kapjuk azt a helyet, akkor mosolyog.
Right, so the equipment is happy.
Látjuk? Oké. Szerintünk ez egy eredmény, amiről érdemes beszélni, amikor egy ilyen biztonsági rendszer.
So this is one achievement. When the manufacturer says that this is the most secure system ever sold on the planet, then this is what we should be looking for. You don't need any special device or knowledge in order to create this image. We had plans to take this photo by photographing the entire audience and pick out a face from among the mass of people, but that would require a lot more time. Doesn't seem to really work. I always say that once this succeeds, that's my success. If it doesn't, it's their failure. How about timing? Okay, let's just carry on with the presentation, but you go on with trying to feed it to the machine and tell me when you manage to do that. I hope you believe me that that paper has nothing special on it. We tested this in the lab, and we continuously test the equipment. It works for most people. We need to monkey around a bit with it, correct the image. We also tested it with various printers. That also counts. But the fact is that you're able to pass an access control system that requires a face by just showing the photograph. Okay, let's talk about the mask I mentioned, the plaster mask. But first, let's see the face recognition equipment of the Suprema, which, by the way, does not accept the paper image. Whether we are able to bypass security with a photograph depends on the infralighting the equipment uses, depends on the reflection properties of the paper material we are using. In this infrarange, a white T-shirt looks totally black. Another color may reflect light so significantly that it makes the task a little bit harder, but still the equipment is able to recognize a face as a face. The other device, I don't know whether you see it, can we focus that? Whatever, this is roughly the same functionality. We created a mask for this, as I mentioned. Arnold laid down on a long bench because Arnold is a tall person, and we put gauze pieces, soaked gauze pieces on his face. You only have to be able to stop breathing for 2 hours, and then you can breathe again. Well, we left him two little holes around the nose, but he still got a red head by the time we finished. Anyway, the gypsum, the plaster, binds after sort of some time. We then get a positive mask using this primary mask. And in this way, you can create the one-to-one face of the person. It depends on the resolution of the material. For instance, the ridges and valleys of a fingerprint require a silicon material that enables fine ridges and valleys to be reproduced. Whether you like it or not, this is his face. He's even smiling. Well, the thing is that we then will need to start to apply some makeup. Well, I'm not really an expert at that, nor are most of us guys. So what we were able to achieve with this was to use chalk to sort of make up this face to something resembling a human, and then we registered it in the equipment, and it went without a hitch. Arnold will show you how this can be done. Now, we probably won't have the time to show you, but Arnold's face and the surface of this plaster shows a very good match. The only problem which makes it impossible to replace Arnold's face with the plaster mask is the different reflection of a human face and the mask. We can't apply appropriate makeup to the face that would provide the same reflection as a human face has. On the left-hand side, you see what we expect from the volunteer, moving the head, face, as part of the registration process. You could say that this was a successful registration. And from this point onwards, the task is, well, this plaster mask can actually go through the access control system. The fact that we are unable to apply good makeup does not mean that an attacker can't, or I may even ask my wife, but I didn't have the time to do that because this was the point to which we wanted to show it to you. If anybody asks us to take it, to do it right up from the beginning to the end, then we can do that as well, but that would require a lengthier
De akkor viszont én
preparation.
azt javaslom, hogy szerintem a fény miatt itt nem fog sikerülni, de próbáljuk ki. Kaptam
Let's
olyan infót, hogy megszakértették a papírlapot.
test it.
És ő a Dávid? Egy kezet kérek ki a
This
Dávid.
is David.
Adhatom a Dávidnak.
Okay,
Köszönjük, Dávid.
his infraphotograph can
Bemegyünk, hova be van regisztrálva.
go through the access control system, just the paper.
Mi volt az oka, hogy nem?
Why didn't it hitch off initially? We had to adjust the image a bit because lighting conditions are not optimal.
Minden esetre az eszköz
Well, anyway, the equipment is happy and I'm happy too.
kaptam a távirányítót.
Okay,
Na,
thanks.
úgyhogy végére értünk a bemutatónknak. Szeretném megmutatni egy kicsit, hogy készült ez a mai előadás. Csak a bemutat, de érdemes megnézni egy-két képet például.
Let's have a look at a few other pictures. For example, what makeup to do for Balázs.
Aztán Balázs egyébként, ő nem Balázs,
But that is not Balázs, that is Bálint there.
elkezdjük tesztelni a
And
berendezést.
once we shall start to test our equipment, we shall map the various characteristic spots. Well, of course, if the manufacturer would just hand it over to us, it would be an easy job. But this is a kind of a black box text because we didn't receive that, couldn't receive that. And then, of course, we shall show that what are those special points where the equipment is sensible to. And we shall cover some parts of the face, down, up, then. But of course, opinions are split because some say that these are not 4 hands, but 2 hands and 4 2 legs, 2 feet. And this is how we can obtain that how the algorithm of the equipment works and how we can obtain data. So thanks for your attention. Now, if Andras, you have still anything to add, you have the floor. Otherwise, maybe the lady will be coming, processing again, showing the time limit. No, the objective for today basically was to see what a tool like this can perform, and that we can somehow dissipate that apparent security which would lure us to think that there is 100% security where there is not one. If we know where the risks really are, then we are on the good path that we can really identify our real problems and find solutions, good solutions to our real problems. So thanks you for your participation, to my colleagues, to the volunteers. Thank you.